Snubbers are used typically to make up for an inductive load that is switched, like by a relay, a switch, a transistor, triac. You don't see it in audio too much right across the transistor, a diode snubber, which is the main snubber you typically run into. But you can also have an RC snubber. Not quite as effective, but it works. There's a cost to putting a snubber across a relay contact or any kind of contact, in that your closing delay, well, your opening delay, I should say, is changed a little bit as this energy comes out of the circuit. So often you're supposed to really derate a relay contact. If you're using it right at its max and you're going to put a diode across it, it's not going to work. You're going to end up burning up your contacts because they won't release smooth, and you get a nice fast sharp release off of a relay without any kind of snubber on it or switch. Once you put a snubber across a switch, that energy's got a path. Anywho, I'm getting off the subject. I really wanted to look at a particular snubber, RC snubber, Borchardt cell. I keep putting an R in there. Borchardt cell, I guess. Borchardt. And I suggest you read the article in Wikipedia. It's a type of Zobel network. And in this case, part of the network is the ESR of the loudspeaker, along with its major inductive component. And what makes the Zobel network different from any other kind of filter is that it's meant to be used in a transmission line, so to speak, a signal transmission line. And rather than just putting a filter in that transmission line, you use a less efficient Zobel network. And like this is used in twisted pair balanced lines, it's used in unbalanced lines as well, like in coax. And you'll see some of these examples look pretty complicated because they're actually for balanced lines. This isn't. This is kind of what you might see in my world. I did CATV line work for a long time, and a lot of these circuits you'll actually find in RF amplifiers for the equalizers, the Bode equalizer or Bode equalizer, the input equalizer, interstage or tilt equalizer. These are pretty similar to what we see in my RF world. In audio, we don't see it quite as much, but you would if it was some of these circuits will probably be balanced too. Let me see if I can find a balanced one. Here's a balanced one for like a balanced line. Which in the old days, everything was 1 volt, 600 ohm balanced line, audio and video. Things are all changing nowadays. Most of the audio and video equipment in a major head end is gone. It's all digital now. It's only rendered at the output. Anywho, it's interesting stuff. It's worth a read.